All right, dude, let's go. Number 10, the Jumbos. In October 2023, a team led by Samuel Pearson of the European Space Agency published findings using NASA's James Webb Space Telescope in the Orion Nebula. Deep infrared imaging had revealed something that planetary formation theory does not account for. Hundreds of free-floating planetary-mass objects drifting through the nebula with no host star, no orbit, no system, just planets, alone in the dark. The part nobody can explain is that some of them come in pairs. The team identified roughly 40 pairs of these objects, now designated Jupiter-mass binary objects, or jumbos. Two planetary mass bodies orbiting each other with no star between them, each roughly the mass of Jupiter, separated by distances wider than our solar system, bound to each other gravitationally, drifting through interstellar space like twin ghosts. Standard planetary formation requires a star. A protoplanetary disk of gas and dust forms around a young star, and planets coalesce within it. Without a star, there is no disk. Without a disk, there is no mechanism. The jumbos should not exist under any current formation model. One theory proposes they formed like stars, from the direct gravitational collapse of small gas clouds. But at Jupiter mass, the clouds would be too small to collapse under standard conditions. Another proposes they were ejected from young star systems. But ejection models cannot explain why so many remained in gravitationally bound pairs. Ejection should separate them, not keep them together. Think about that. Right now, somewhere in the Orion Nebula, there are planets drifting through complete darkness with no sun to orbit. Some of them travel in pairs, circling each other with nothing else around them for light years, and nobody can explain how they got there or what made them. Hundreds of rogue planets, dozens of bound pairs, no star, no disk, no formation model, just objects that exist where physics says nothing should. Number 9. The Diamond Pulsar Planet. In January 2026, a team led by Michael Zhang of the University of Chicago published a study in the Astrophysical Journal Letters describing a planet unlike anything previously catalogued. PSRJ 232-2650b orbits a millisecond pulsar, a neutron star spinning hundreds of times per second. The planet has a mass comparable to Jupiter. Its shape is stretched, lemon-like, distorted by the gravitational field of the dead star it circles. The part that baffled planetary scientists wasn't the shape. It was the atmosphere. The atmosphere is dominated by helium and carbon, not the hydrogen-helium mix found on every other known gas giant in the entire catalog of discovered worlds. Carbon and helium. No hydrogen to speak of. Under the extreme pressures inside the planet, the carbon is likely compressed into solid diamond. A planet with a diamond interior, orbiting the spinning corpse of an exploded star. Roger Romani of Stanford, one of the world's leading experts on these systems, responded directly. Did this thing form like a normal planet? No, because the composition is entirely different. Did it form by stripping the outside of a star? Probably not, because nuclear physics does not make pure carbon. The pulsar it orbits is the remnant of a supernova. The explosion that created the neutron star should have destroyed any nearby planet, vaporized it, scattered its atoms across light years of space, and yet this one is still there, with an atmosphere that no known formation pathway can produce, with an interior that may contain more diamond than any object ever observed, orbiting a dead star that should have killed it, a planet made of carbon and diamonds, orbiting a dead star formed by a mechanism that nobody can identify. Every formation model fails. The planet doesn't care. Number 8. The Red Monsters. In November 2024, an international team published findings in Nature from the JWST Fresco survey. 3 ultra-massive galaxies had been confirmed within the first billion years after the Big Bang. Their stellar masses were comparable to the Milky Way. Garth Illingworth of UC Santa Cruz, who helped develop the original concept for JWST-3 decades ago, was a co-author. What makes this strange is the clock. There wasn't enough time. Standard cosmological models predict that early galaxies should be small and chaotic, converting roughly 20% or less of available gas into stars. These 3 galaxies converted gas into stars at nearly double that rate. Milky Way mass galaxies, assembled when the universe was barely 5% of its current age. Imagine you visit a nursery and find toddlers the size of full-grown adults. Not 1. 3. In the same room. You would not question the toddlers. You would question everything you thought you knew about how growth works. Illingworth described it directly. The existence of such massive galaxies at the earliest times poses a real conundrum. The fresco data showed these were not measurement artifacts. The spectroscopic confirmations were precise. The masses were real. If 3 were found in one small patch of sky, the implication is that there may be many more. Everywhere James Webb looks in the early universe, it finds structure that arrived ahead of schedule. The model said the universe needed billions of years to build galaxies this massive. James Webb found 3 of them in the first 700 million. The universe was assembling itself faster than anyone thought possible. And the question nobody can answer is how. Number 7. TOI 6894b. In June 2025, scientists using data from the James Webb Space Telescope confirmed the existence of TOI 6894b. It is a gas giant roughly the size of Saturn. That is not unusual. What is unusual is where it was found. The part that broke formation models wasn't the planet, it was the star. TOI 6894b orbits a red dwarf, a small, dim star with a fraction of the Sun's mass. Standard planet formation theory is built on a core accretion model. Solid material in a protoplanetary disk gradually accumulates until it reaches a critical mass, then rapidly sweeps up surrounding gas to form a giant planet. The amount of material available scales with the mass of the star. A star this small should not have had enough raw material in its disk to build a Saturn-mass planet. The planet exists anyway. The disk that should have been too small produced a gas giant that should have been too large. The formation mechanism that explains every other gas giant in the known catalog does not explain this one. It is the equivalent of finding a mansion in a village with no building materials. The house is there. You can measure it. You can photograph it. But there was never enough wood, stone, or steel in the entire village to construct it, and nobody saw it being built. A gas giant around a star too small to make one. Formation theory says it's impossible. The planet says otherwise. Number 6. The Methuselah Star. The star is designated HD 140283. Informally known as the Methuselah Star, it sits roughly 190 light-years from Earth in the constellation Libra. In 2013, a team led by Howard Bond of Pennsylvania State University published a refined age estimate using Hubble Space Telescope data. 14.46 billion years, plus or minus 800 million. The universe is 13.8 billion years old. The central estimate places this star roughly 660 million years older than the universe itself. The error bars allow it to be slightly younger, but the best fit value says it predates the Big Bang. A star older than the container it exists inside. A clock that says the thing in the box was ticking before the box was built. HD 140283 is extremely metal poor, containing almost no elements heavier than hydrogen and helium. That composition is consistent with formation in the earliest epoch of the universe, when heavy elements had not yet been produced by stellar nucleosynthesis. This star was among the first generation ever formed, and its age says it may have been forming before there was a universe to form in. JWST has continued to refine our understanding of ancient stellar populations in the Milky Way's halo. The tension between the age of HD 140283 and the age of the universe has not been fully resolved. The error bars are large enough to technically allow compatibility, but the central estimate has not moved. If the best measurement is correct, this star watched the Big Bang happen. It was already burning when the universe began. That is not a rounding error. That is a star that physics says cannot be that old. It is that old anyway, and it is still burning right now, 190 light-years from where you are sitting. Number 5. CAPERS-LRD-Z9. In 2025, a team led by Anthony Taylor of the University of Texas at Austin published findings in the astrophysical journal Letters confirming a growing supermassive black hole at redshift 9.288. The object, designated CAPERS-LRD-Z9, existed when the universe was approximately 500 million years old. It is the most distant object ever confirmed to contain an actively growing supermassive black hole. The part that unnerved astrophysicists wasn't the distance. It was the mass. Supermassive black holes contain millions to billions of solar masses. Building one takes time. The Eddington limit defines the maximum rate at which a black hole can consume matter before radiation pressure pushes incoming material away. At the Eddington rate, growing a supermassive black hole from a stellar mass seed takes far longer than 500 million years. Taylor's team ran the numbers. A standard 100 solar mass seed accreting at the Eddington rate cannot reach the observed mass in the time available. The math does not work. Either the black hole started from a massive seed exceeding 10,000 solar masses, which requires an unknown formation mechanism, or it grew at super Eddington rates, which breaks the theoretical accretion limit that governs how black holes feed. Something is building black holes faster than physics allows. The mechanism is unknown. The speed limit that was supposed to govern how mass accumulates in the universe may not exist. And if the speed limit doesn't apply to black holes, the question becomes what else in the universe is growing faster than we thought. Because James Webb is not finding one anomaly, it is finding a pattern. Every time it looks at the early universe, something is too big, too fast, too soon. The models say a black hole this massive, this early, requires either an impossible seed or an impossible growth rate. James Webb found it anyway, and it is not the only one. Number 4. NGC 1052-DF2. In 2018, Peter Van Dockum of Yale University published a study in Nature announcing the discovery of NGC 1052-DF2, a galaxy with little to no dark matter. A follow-up confirmed a second such galaxy, NGC 1052-DF4. Both are ultra-diffuse galaxies roughly 60 million light-years from Earth. The implication nobody expected was that the one ingredient every galaxy formation model requires might be optional. Dark matter is not a detail in galaxy formation, it is the foundation. In the lambda CDM model, galaxies form inside halos of dark matter. The dark matter collapses first, creating gravitational wells that pull in normal matter. Without the dark matter halo, there is no scaffold. Without the scaffold, the gas does not collapse. Without the collapse, no stars form, no galaxy forms. Dark matter is not a seasoning, it is the architecture. Remove it, and the building should not stand. NGC 1052-DF2 has the size of a diffuse galaxy, but the gravitational behavior of an object with almost no dark matter. Its globular clusters move at speeds consistent with the visible mass alone. The dark matter fraction is consistent with 0. Think about what that means. The scaffolding that holds the universe's structure together, the invisible framework that everything is supposed to be built on, is missing, and the galaxy is still there. It formed anyway, without the one thing every simulation says you need. One proposed explanation is tidal stripping, where a nearby massive galaxy pulled the dark matter away after formation. But how a galaxy survives having its foundation ripped out from underneath it is itself unexplained. The scaffolding that holds the universe together may have an exception nobody accounted for. These galaxies exist without it, and if they can exist without it, the question is what dark matter actually does, because the answer may not be what we thought. Number 3. Dark stars. In October 2025, a study published in the Astrophysical Journal Letters reported that certain early universe objects observed by JWST match the predicted spectral signatures of a hypothetical class of object that has never been confirmed. Dark stars. The theoretical framework was developed by Catherine Fries of the University of Texas at Austin and Cosmin Ely. The reason this unsettles physicists is not the speculation, it's that the observations fit. In the Standard Model, the first stars, known as Population 3, were massive hydrogen-helium giants, powered by nuclear fusion. They burned hot, lived fast, died young, and seeded the universe with the first heavy elements. Every model of cosmic chemical evolution begins with them. Dark star theory proposes something different. Before Population 3 stars ignited, the first luminous objects in the universe may have been powered not by fusion, but by dark matter particles annihilating inside enormous hydrogen clouds. These dark stars could have grown to millions of solar masses. They could have shone for millions of years. They would have looked like stars from the outside, but functioned on an entirely different engine. JWST observations of certain early objects show spectral features that align more closely with dark star predictions than with Population 3 models. The match is not definitive. The data is insufficient for confirmation, but it has not been ruled out. If dark stars existed, they would be the first direct evidence that dark matter does something other than pull, that it interacts with normal matter in ways the Standard Model of particle physics does not predict. The first chapter of cosmic history, The one that explains where the first light came from would need to be rewritten, and the 341 little red dots that nobody can explain might finally make sense, because they might be the descendants of something that was never supposed to exist, stars that run on dark matter instead of fusion. The theory existed for years. James Webb may have found the evidence. Nobody can confirm it. Nobody can rule it out. And nobody wants to be the one who publishes the paper that says the first stars in the universe were not really stars. Number 2. The little red dots. In the summer of 2022, just weeks after James Webb began delivering scientific images, astronomers noticed an unexpected pattern. Tiny red points scattered across the deepest observations. Compact, brilliant, red, and everywhere. By 2025, 341 had been cataloged. They existed between 600 million and 1.6 billion years after the Big Bang. Then they vanished from the cosmic record. An entire class of objects that appeared, burned for roughly 1 billion years, and disappeared. What makes the little red dots the strangest discovery in modern astronomy is that after 3 years of study, nobody can agree on what they are. They are too bright to be normal early galaxies, too compact, 1/10 the size of typical galaxies but shining just as intensely. They do not emit the X-rays or radio waves that characterize feeding black holes. They do not match any known galaxy type. They do not match any known stellar population. They sit outside every existing classification system. Fabio Pacucci of the Harvard Center for Astrophysics called them arguably the most surprising discovery by JWST to date. In January 2026, a study published in Nature by Darach Watson of the University of Copenhagen offered the leading explanation. The little red dots are young black holes, 100 times less massive than previously estimated, enshrouded in dense cocoons of ionized gas. The black holes devour the gas, generating enormous heat that glows through the cocoon, producing the characteristic red color. Watson's team proposed calling them black hole stars, an entirely new class of object that was never predicted by any theoretical framework. Rohan Naidu of MIT now prefers the same term. He describes them as objects that effectively radiate like enormous stars, despite being powered not by fusion but by accretion. They can be 1 trillion times more luminous than our sun. 1 trillion. Powered by a black hole eating gas inside a cocoon that makes it look like a star, that existed for 1 billion years and then vanished. And until 2022, nobody knew they were there. 341 objects, no classification, 1 billion years of existence, then gone. The strangest things James Webb has found are not planets or galaxies or black holes. They are something else, something that existed before any of those categories were useful, something we don't have a word for yet. Number 1, MOM-Z14. In February 2026, astronomers announced the discovery of MOM-Z14 using data from James Webb collected in April 2025. Published in the Open Journal of Astrophysics, MOM-Z14 is the most distant galaxy ever confirmed. It existed just 280 million years after the Big Bang. The universe was barely 2% of its current age. The part that should not be possible is not the distance. It's what they found inside. Standard models predicted that galaxies at this epoch should be small, dim, and chemically primitive, almost entirely hydrogen and helium. The first generation of stars should barely have begun to form. Complex chemistry should not yet exist. The cosmic dawn was supposed to be simple. Dark, quiet, the universe waking up slowly. MOM-Z14 is brighter than predicted, more compact than predicted, and it contains elevated levels of nitrogen. Nitrogen does not form in the Big Bang. It requires stars to have already formed, burned through their fuel, and exploded as supernovae, scattering their processed elements into the surrounding gas. Then a second generation of stars must form from that enriched gas. That cycle, birth, death, enrichment, rebirth, takes time, hundreds of millions of years at minimum. MOM-Z14 completed it in 280 million. The galaxy has also cleared its surrounding region of primordial hydrogen gas. At this epoch, the universe was still filled with neutral hydrogen, a fog that had not yet been burned away by starlight. MOM-Z14 appears to have burned through its neighborhood like a furnace in a dark room. Co-author Peter Van Dockum of Yale: I don't think any of us expected to break the redshift record. Co-author Chuajian Shen: There is a growing chasm between theory and observation related to the early universe. Every entry in this video describes something James Webb found that should not exist. Planets with no star, diamonds around dead suns, galaxies too massive for their age, a star older than the universe, black holes that grew too fast, galaxies without dark matter, stars that might run on dark matter, 341 objects nobody can name. But entry 1 is what ties them all together, because MOM-Z14 is not just one anomaly. It is a universe that was already complex, already evolved, already chemically enriched when it was supposed to be empty and dark and simple. The models said the dawn should be quiet. James Webb pointed its mirror at the dawn and found a universe that was already awake, already building, already old, 280 million years after the beginning. The strangest thing James Webb has found is not any single object. It is that the universe it was built to study does not match the universe it keeps finding. Every observation pushes the discrepancy further. Every record broken reveals something that should not be there yet, and the telescope is not done looking. If you want to see more videos like this, click the video on screen now and make sure to subscribe.